Calculate the number of moles of magnesium in the 0.0360 grams sample. 1 moles mg slash 24.30 grams mg times 0.0360 grams equals 0.00148 moles mg. 1 point is earned for the correct number of moles of mg. Note: for errors in significant figures or mathematics, there is a 1-point deduction. For the entire question, only 1 point total can be deducted for each type of error. Calculate the number of moles of HCl needed to react completely with the sample of magnesium. 0.00148 moles mg times 2 moles H plus slash 1 moles mg equals 0.00296 moles HCl. 1 point is earned for the correct number of moles of HCl. As the magnesium reacts, the hydrogen gas produced is collected by water displacement at 23.0 degrees Celsius. The pressure of the gas in the collection tube is measured to be 749 torr. Given that the equilibrium vapor pressure of water is 21 torr at 23.0 degrees Celsius, calculate the pressure that the H2 produced in the reaction would have if it were dry. P equals 749 torr minus 21 torr equals 728 torr. 1 point is earned for the correct pressure. Calculate the volume, in liters measured at the conditions in the laboratory, that the H2 produced in the reaction would have if it were dry. PV equals nRT gives V equals nRT slash P. 728 torr times 1 atmospheres slash 760 torr equals 0.958 atmospheres. V equals 0.00148 moles H2, 0.0821 liters atm moles to the power -1 Kelvin to the power -1. 296 Kelvin slash 0.958 atmospheres equals 0.0375 liters. 1 point is earned for the correct moles of H2. 1 point is earned for agreement of units of P from part C and R. 1 point is earned for the correct temperature substitution and calculated volume. The laboratory procedure specified that the concentration of the HCl solution be 2.0 molar, but only 12.3 molar HCl solution was available. Describe the steps for safely preparing 50.0 milliliters of 2.0 molar HCl using 12.3 molar HCl solution and materials selected from the list below. Show any necessary calculation. 10.0 milliliters graduated cylinder. Distilled water. 250 milliliters beakers. Balance. 50.00 milliliters volumetric flask. Dropper. 2.0 moles HCl slash 1000 ml times 50.0 milliliters equals 0.10 moles HCl. 1000 ml slash 12.3 moles HCl times 0.10 moles HCl equals 8.1 milliliters. Pour some distilled water into the volumetric flask so it is about half full. Use the graduated cylinder to measure 8.1 milliliters of 12.3 molar HCl and pour it into the volumetric flask. Add a few ml of distilled water to the graduated cylinder, swirl, and add the liquid to the volumetric flask. Swirl the flask to mix. Carefully add more distilled water to the flask, using the dropper for the last few ml to fill the flask to the mark with distilled water. 1 point is earned for calculating the correct volume of 12.3 molar HCl. 1 point is earned for adding acid to water in the dilution process. 1 point is earned for filling the volumetric to the 50.00 milliliters mark with distilled water.